In this video, we will learn how to find out the demand function from the utility function. The question is given the utility function, that is u is equal to x1 raised power 2 times x2 raised power 3, and budget constraint is m is equal to p1 x1 plus p2 x2, where x1 and x2 are the two goods. P1 and P2 denote the price of good x1 and x2. M denotes the income. We have to find out the demand function for good x2. Options are being given us as 3m upon 5p2, and similarly we need to find out the correct option. Okay, so this is a case of utility maximization. So our endeavor is to maximize utility, which is equal to x1 square times x2 cube, subject to the budget constraint that he is facing, that is, if I rewrite it like this, p1 x1 plus p2 x2 should be equal to the income of the consumer. Okay, so consumer's endeavor is to maximize his utility subject to the budget constraint. Graphically, what is meant by this? So if I draw a small graph here, we have x1 on the horizontal axis, x2 on the vertical axis, with the given budget line. Okay, with the given budget here, consumer wants to reach the highest possible utility. Okay, or indifference curve. So utility will be maximized where the slope of the indifference curve and the slope of the budget line are tangent to each other. So at this point we will get the demand function for good x and x1 and x2. Okay, so we know that at equilibrium what happens? At equilibrium or at utility maximization, this condition must hold, that is MRS of good 1 and 2 should be equal to the ratio of the prices P1 upon P2. MRS is the slope of the indifference curve, P1 upon P2 is the ratio of the prices. This denotes the slope of the budget line. MRS, as we know, it is simply the ratio of the marginal utility of good 1 upon marginal utility of good 2, and it should be equal to the price ratio, that is P1 upon P2. Okay, now marginal utility of good x means the change in the utility due to the consumption of the good x1. Similarly, mu2 means the change in the utility due to the change in the consumption of good 2 should be equal to the ratio of the prices P1 upon P2. Now du upon dx1 means the partial derivative of this function with respect to x1. So derivative of x1 square is 2x. So we get 2x1 and x2 will remain same because we are taking partial. Symmetrically, the derivative of this function with respect to x2, this time the coefficient exponent of x2 will become coefficient. So we have 3 times x1 square will remain same, but x2's exponent will get subtracted, it becomes square. By power function rule, if we have x raised power n, its derivative is n times x raised power n minus 1. Here we have x2 cube. So 3 times x2, 3 minus 1, which became 3x2 square. Okay. So then let me rub this explanation here. Should be equal to the ratio of the prices P1 upon P2. So let us simplify it. So we have 2 upon 3. Let us transpose this x1 here and this x2 there. So we will get x2 cube times x2 if it is square, it becomes negative 2. Exponent, if I transpose numerator to denominator or vice versa, exponent sign changes. Similarly, here we have x1, we have x1 square. If I transpose this here, it gets multiplied, but it is what we call exponent sign changes. So it is minus 1, should be equal to P1 upon P2. So we got here, so we have 3 times, bases are same, so we have 3 minus 2 is 1, so we get x2 divided by here 2 minus 1 is 1, so we get 3x1 should be equal to P1 upon P2. Okay, solving further. Okay, so we have 2 here, so let me write here 2 upon 3. So let us solve it for x2. So x2 will be equal to that will be equal to P1 upon P2. If I transpose this x1, it will get multiplied, it becomes x1, and if I transpose 2 upon 3, it becomes 3 upon 2. 3 upon 2. Okay, now what we need to do, we plug the value of x2 is equal to this stuff into the budget constraint. Okay, so here we put the value, which implies we have p1 x1 plus p2. In place of x2 we have this stuff, that is 3 upon 2 p1 upon p2 times x1 should be equal to m. Here p2 and p2 will get cancelled, so we get here p1 x1 plus 3 p1 x1 upon 2 should be equal to m. So do the cross multiplication here. So we have 2 p1 x1 plus 3 p1 x1, so it becomes 5 p1 x1 divided by 2 should be equal to m. Let us solve it for x1, or x1 will be equal to, so we have here m, transpose this, it becomes 2 upon 5. So x1 is in the numerator, it goes to, so rather p1 is in numerator, it goes to denominator. So this is the demand function for good x, but we are supposed to find out the demand function of good x2. Okay, now we plug the value of x1 is equal to in this stuff into this equation, okay, to find out the demand function for good x2. So x2 will be equal to, so we have 3 upon 2 times p1 upon p2, and the value of x1 is 2 upon 5 times m upon p2. Okay. Sorry, here it is p1. Okay, we have here p1, so here we have p1. Okay, so p1 and p1 gets cancelled, 2 and 2 gets cancelled, so x2 will be equal to, we have 3 times the income divided by 5 p2. This will be the demand function for good x2, which we were supposed to find out. Okay, I hope I make myself clear in this video and you find out this video helpful. Thank you.